Hello kids. This presentation is intended as a review of the scientific method, which is one of the topics introduced this term in the subject of physics. So we are going to talk briefly about the scientific method. I am going to explain again what the main steps of the scientific method are, and after that you're going to solve a little worksheet that is in a format of a Google form. You can find that worksheet by going to a link in the Padlet where you found this video. So let's start. Well, here you can see a flux diagram which represents the scientific method. And this may be a little complex for you, but don't worry because I am going to guide you through this flux diagram. And the scientific method is the main difference between what is considered as science and what is not considered science. Remember our discussions during the classes at the very beginning of this term. So let's look at the top part of the diagram, and you can see that there are two steps that are like closed in a circle, because the first two things that you can see there, ask a question and do background research, are part of the observation. Remember, we talked about many examples in which you can observe a phenomenon that is occurring, and then you can ask a question about that phenomenon. Remember maybe the example where one student is playing with a ball inside the classroom and it hits the glass, but it doesn't break it, or it breaks. So you can ask the question, why does it break, or why it doesn't break, what conditions does it have to have in order to break or not. And after asking the question, you should do background research. That means that you need to make a little investigation about all of those things. So if we keep going with the example of the glass, so you should start investigating or researching the properties of the glass, the conditions for breaking, the conditions for not breaking, and all of the possible things that may be related to that. So after that, after asking a question, you have to construct a hypothesis. That is the next step on this diagram, construct a hypothesis. So we are going to briefly talk about hypothesis a little bit later because that was our main focus this term. But let's continue with this diagram. So after you create the hypothesis, which is tentative answer to that question, which has the characteristic that it is testable, so you can test it, and it makes a prediction, which is something that we talked about a lot during our classes. So after you create that hypothesis, you have to test that hypothesis with an experiment. You have to design a situation that you can control in order to test it. So then when you are doing the experiment, you have to think if the procedure is working or if it's not working. So if it's working, perfect. Yes, it is working. Now you have to analyze the data that you collect with the experiment, and with that information, you have to make a conclusion. But if it's not working, there you can see that the arrows lead to the no and then lead to a little box on the left that says troubleshoot the procedure and carefully check all steps and setup. So what does that mean? In Spanish, troubleshoot means like to fix, arreglar, corregir los errores. something like that. So you have to check your experiment, because maybe that is something that you are not controlling properly. And be careful, because here we can introduce the concept of variable. A variable is something that changes. Remember our statistics class. In statistics, we had variables, something that changed from person to person, but that came from questions that we made. But in physics, variables are similar, but also a little different. Variables in physics are all of the possible outcomes, or all of the possibilities that may change during an experiment. So for example, in the question, sorry, not in the question, in the example of the class, there are many variables. For example, the like the width of the glass, its surface area, the strength that the student uses to hit the ball, the diameter of the ball, which is a sphere. All of those things may change and may affect if if your experiment is working or not. So when you troubleshoot, when you fix those things, you have to make the experiment again if it didn't work. And after that, you have to do it until it actually works, to finally make an analysis of the data that you collect with that experiment and make conclusions. So once you make the conclusions, two things can happen. Look at the purple boxes in the bottom part of the slide. So one thing is that it aligns with the hypothesis. So what you see in the experiment is what you expected from the hypothesis. The answer that the experiment gives you is the same answer that you tentatively imagined, created, developed before as a hypothesis. So after that, you have to communicate your results. It may be through a paper, through many medium that you can use, but we will talk about later when we actually need that. But something else can happen, is that the results align partially. Partially means like a little bit, but not completely, parcialmente, or not align at all with the hypothesis. So your hypothesis was completely wrong, and nothing that you predicted actually resulted by the experiment. So you can communicate the results, and you can say, okay, my hypothesis was wrong because this happened and the experiment drove these conclusions. But you can also follow the little dotted arrow that goes up again. Please look at the yellow box at the right of the diagram. It says experimental data becomes background research for new future project, and ask new questions, form new hypotheses, experiment again. Because, okay, what happens if the results don't align or align a little bit with your hypothesis? Well, so your question may not be answered. So your conclusions are now something that that work as the basis for future researches, future investigations that may allow other people or yourself to create new hypotheses and make new experiments and make new research. So basically, that is how the scientific method works in a very brief way, um, and in not a complex way to understand, because obviously we can make it a little bit complex by getting deep in the theory of the scientific method. But remember, we are going to do it step by step, and we are going to do it in such a way that you understand everything. So kids, I want you to go right now to the link of the questionnaire, a little worksheet that I created. Um, based in another person worksheet. Go for it, go click it, get inside, and please try to solve it. And once you finish, you will be able to see the answers. Now, if you have any question, don't forget that I am always available through Fidia, so please feel free to ask as many questions as you want in order to make this review a little bit more understandable. So please try to solve that questionnaire, and we will see in a live session through Google Meet on Friday. Thank you very much, kids, and see you next time.